Hello students, welcome everyone, welcome to your favorite channel Vedantu NCRT Solutions. In this channel, you'll get the detailed description of each and every NCRT questions and you will be able to solve it easily and understand it easily. So in this session, we are going to solve question number 7 of exercise 1.2 of your chapter relation and function. Let us try to read the question first. In each of the following cases, state whether the function is 1, 1 and onto or bijective. Justify your answer. See, we need to check whether the given function is 1, 1 or onto. Let us first take the first sub question, children. First sub question, it is a function where the domain and codomain both belongs to set of real numbers and f of x is given as 3 minus 4x. This is a given function. Now see children, we know how to check whether it is 1, 1 whenever you get a polynomial function or a linear function or linear polynomial like this, children. How do you check? As we have discussed before, if you are taking the values f of x1 and f of x2, if f of x1 and f of x2 is giving you the same value, that means x1 must be equal to x2. That means you're talking about the same x value. There are no two value in the codomain which is linked to the same element in the domain, correct? In that case, you can prove that is 1, 1. Now let us check for this, whether this condition is valid. Now let us see, when we do f of x1 is equal to f of x2, what happens in this function? Observe this carefully, children. F of x1, if I am writing, it becomes 3 minus 4 times x1, which is equal to 3 minus 4 times x2, correct? Now, if you cancel 3 and 3, 4 and 4, what is remaining? You will get x1 is equal to x2. If x1 is equal to x2, then what do we conclude? We write f of x is a 1, 1 function, right, children? F of x is 1, 1. So we can write the given function is a 1, 1 function. Now let us try to check whether the given function f of x, which is equal to 3 minus 4x, is onto. Now if you're checking for onto, what do you need? If you substitute, if you are able to get f of x is equal to y, that means in the function x, if you can write that in terms of y, and when you substitute, if you are getting f of x is equal to y, then that is a conclusion that the given function is onto, yes or no? Now if 3 minus 4x is y, children, how can you write x in terms of y? We can write minus 4x is equal to y minus 3. In that case, x can be written as 3 minus y divided by 4. Right, children? You took minus 4 down. It becomes y minus 3 divided by minus 4. I just took the minus sign to the numerator. It becomes 3 minus y. Now, if you are able to substitute this, means if you are able to substitute f of 3 minus y by 4 in the given function, what happens? Just check. It becomes 3 minus 4 into 3 minus y whole divided by 4. Y gets cancelled, 3 gets cancelled. What you're getting, children? You're getting y. Yes, 3 and 3 gets cancelled, 4 and 4 gets cancelled, remaining is y. So you got f of x is equal to y. So what do we conclude? It is onto. So this function is 1, 1 as well as onto, right? So it is a bijective function, right, children? So first sub question, it is 1, 1 and onto. Now let us try to solve the second sub question here. Observe this very carefully. In the second sub question, the domain belongs to a set of real numbers, codomain also belongs to a set of real numbers, and they have given f of x as, what is f of x? 1 plus x square. Observe this very carefully. 1 plus x square is given. Now let us try to check for 1, 1 like how we have done for the first sub question, right, children? What do? F of x1, we need to equate with f of x2 and check whether x1 is equal to x2. Now if you're doing this, I will get 1 plus x1 square is equal to 1 plus x2 square. 1, 1 gets cancelled, but under this case, can you write x1 square is equal to x2 square and conclude x1 equal to x2? No. If x1 square is equal to x2 square, that means we have a conclusion x1 is not equal to x2, children. It can be minus x2 also, right? So in that case, what we can write? F of x is not 1, 1, right, children? Take a function minus 1. 1 plus minus 1 the whole square also gives you 2. 1 plus 1 the whole square also gives you 2. In that case, for two different value in the domain, you have the same value in the codomain, correct? So f of x is not 1, 1. So what do we write here? We write f of x is not a 1, 1 function. Now let us check for onto. So f of x is not 1, 1. We will conclude this. Now onto, if you want to check for onto function, observe this very carefully, children, since I have given set of real numbers. In your codomain, if you have the value minus 2, like how we have taken for the previous problem, consider f of x is minus 2. Do you have any value in the codomain for this? Is there any value can be mapped in the domain for the codomain value minus 2? No. You can write for f of x is equal to -2, there is no value, of x in the domain, right children? True, no? Yes, in that case what we write? We write that f of x is not on 2, so what happens? We can write it is neither on 2 nor 1 1, or it is neither 1 1, nor onto function, right children? Neither 1 1 nor onto. So easy and simple question. I hope my children have understood this. And see children, if you are understanding all these questions, like, share and subscribe, share it with your friends so that even they can solve all these questions easily and score more in your examination. Thank you.